So this is about the nomenclature of alkanes, and once you know the nomenclature of alkanes, you can pretty much name almost anything because it gives you the fundamentals, okay, for how to do nomenclature. So the first thing that we have to do for any kind of an alkane nomenclature, if we are given the straight chain, is to find the longest chain. Okay, so let's start our numbering. So 1, 2, 3, 4, 5, 6. But I see a chain going up also, and I can see if that one has the longest, if that's the longest chain. And so 1, 2, 3, 4, 5, 6, and it is not. Okay, so they are both the same. So which means that my longest chain or my base name is hexane. Okay, so now we look for substituents. Okay, and the substituents we have is one over here, and that is a methyl. And this is how I do my stuff. Okay, is I identify the different substituents I have, and then I will figure out the numbering. Okay, and so then here we have the ethyl. Okay, so I have two substituents. Now, the rule that we have is that where do you start the numbering? The numbering starts from the closest to the end. Okay, so if you have to number your substituents, the numbering should start, that is, closer to the end. So let's go ahead and do this. 1, 2, 3, 4, 5, 6. Okay, so the green one is one of the numbering if I start from the right hand side. Okay, so what if I go from the left hand side? And I'm really sorry, this is going to get a little bit messy, but sometimes, you know, mess is good. Or maybe I don't need to do that, right? Because the red one is already there. Okay, so we'll just follow the red one. So in the red one, we have the 1, 2, 3, 4, 5, 6. So in both cases, my lower number is the number 3. Okay, so now I have to determine what's going to be my number 3. Is it going to be ethyl or is it going to be methyl? So here, the next rule is that your substituents that you have, the substituents should be in alphabetical order. Okay, not chronological order, alphabetical order. So here what I get to do is that I get to put them actually in chronological order as well as alphabetical order. Okay, so my name then for this compound is going to be ethyl. I leave some space in the middle for the numbers methyl hexane. Now there is no space between methyl and hexane. Okay, it's supposed to be all one. So now I have to put the locant, and for ethyl it's going to be 3 because on the third carbon I have ethyl, and then on the fourth I have the methyl. I have to put a dash between a number and an alphabet. Okay, so a number and an alphabet gets a dash. So that's my name, not my name, the compound's name. So 3-ethyl, 4-methyl hexane. Okay, let's go ahead and do the next one where we have a long chain. So generally what we end up doing is when we see a long chain horizontally, we go ahead and number that. And then we start looking things around if we do. Okay, and sometimes you all don't, and so I want to tell you that it's okay that if you want to start from here, so 1, 2, 3, 4, 5, 6, and then 7. Okay, so this is all fine, but the thing is that this is not the longest chain. Okay, and so the other numbering that we have is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's the other numbering, and that's the numbering we have to follow, not the numbering, the number of carbons we have to follow, because that is the longest chain. Okay, so which means that my base name is going to be nonane. Okay, that's what it's going to be. So now I'm going to go ahead and find out all my substituents that I have. So starting from 1, 2, so right here I have a methyl group, here I have a methyl group, and here I have a methyl group as well. So now I need to figure out how to do my numbering, because my numbering should be lower numbers. That's the other rule. Okay, so lower numbering mean it should be closest to the end of the chain. Okay, so whether it's this chain or towards this end of the chain, the numbering should be lower numbers. Okay, so it seems that I think I may have a little bit of a problem. So with the purple numbers, okay? So the way I have it numbered in the purple color, that may not work. So I'm going to go ahead and do this in a different color. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I hope you can see all that. So now in this case, my methyl that's on the right hand side, this will be 3-methyl. The methyl that I have here will be 4-methyl, and then the last methyl that I have is going to be 7. Okay, methyl over here. All these are lower numbers. If I were to number from the left hand side with the purple numbers, okay, if I were to do these numbers, then it would be larger numbers. So I can't have larger numbers, I have to keep lower numbers. Because I have the same kind of a group on there, I'm going to go ahead and say it is trimethyl. Okay, trimethyl. Nonane, of course, is my base name. So trimethyl tells me I have 3 methyl groups. What are my locants? My locants means the location of the methyl groups is 3, 4, 7 dash trimethyl nonane. Okay, so these 3 numbers over here, these are called locants, and any kind of number is called a locant. The trimethyl, tri tells me I have 3 methyl groups, and nonane, of course, is my longest chain. Okay, that's how this works. Okay, let's look at the next one. Now we are actually in cyclic compounds. And in case of cyclic compounds, the one rule that you have to follow is if you have a long chain attached to a cyclic compound, you have to see which one has more carbons. Okay, so whatever has more carbons is going to get the base name. Okay, so in this case, we don't have to worry about it because the substituents that we have are pretty small. Okay, so this is a methyl group, this is an ethyl group, and here again we have a methyl group. Okay, so all of these separately, of course, they are less than 6 numbers, so we don't have to worry about that. So let's go ahead and count our number of carbons that we have here. So 1, 2, 3, 4, 5, 6. So this is a 6-carbon ring, so this means that it is a cyclohexane. Okay, that is my ring, that's my base name. So now what's going to happen with the numbering? Okay, the numbering here actually has to be still lower numbering, but where do I start? Okay, so in this case, because I have a substituent on each carbon next to each other, I can start anywhere I want. I can start with this methyl group or I can start with this one because both of them will give me lower numbers. Okay, so it doesn't matter where I start. So the only thing I want to follow is that it should be alphabetical. All right, so ethyl group is going to come in first. So which means that I have 2 ethyl, and then I have 1, 3, and I'm going to run out of space here. I knew that. So dimethyl cyclohexane. Okay, so that's how this one works. And if your substituents are far apart, okay, so if you had something like this and this and this, okay, so in this case, if you were to do the numbering, you would actually start from the ethyl group, okay, because this will give you 2 lower numbers, 1, 2, 3, and then this would be 4. Okay, that would give you the lower numbers in there. If you, and you can try numbering in different ways and see which one gives you the lowest numbers. You could try from the methyl group, okay, and see how that numbering goes. So it's 1, 2, 3, 4, 5. So that's not going to work, okay, because then one of the group is getting a higher numbers. So you want to make sure that you keep the lowest numbers possible, okay? So that's how you work cyclic compounds. All right, so let's look at the next one now. Here you actually have 2 rings that are joined together by a bond. All right, so you can have 2 rings like this, and you can also have 2 rings like this. Okay, so there is a difference between these 2 rings. All right, so this one, there's actually a bond between the two. These 2 are actually called fused. Okay, and we will do this one because these later on. Okay, and these are actually bicyclic compounds. So this is a little bit different, so don't confuse the 2 of them. The bonding is a little bit different, okay, for both. So in any case here, if you have the 2 rings, your base name is going to be the one for the larger ring. Okay, the larger ring here is cyclopentane. That is the larger ring. Now you only have one substituent in there. So if you have only one substituent, you don't have to worry about numbering it, okay? Because it's a ring. It can be anywhere. It doesn't matter. And then what is the substituent? This substituent is a 3-carbon ring. So 3-carbon means propyl, right? So a propyl group, but it's not just a propyl group. It's actually a cyclopropyl group. So cyclopropyl cyclopentane. Okay, that's the name of this compound. And you chose cyclopentane as your base name because this is a larger ring. Okay.